In this video, we'll take a look at an example of a synthesis reaction. So write the balanced equation for the synthesis reaction between cobalt and sulfur. So both cobalt and sulfur are elements found in the periodic table. So the first thing we're going to do is identify the elements that are involved. So cobalt, or Co, is a metal, and sulfur, or S, is a non-metal. And then the next thing we're going to do is determine the type of compound that they will form. So a metal and a non-metal are going to make an ionic compound. So that means that I can predict the product and come up with its formula. The second thing, if there's a metal, is determine whether it's multivalent, and then if so, what are the charges? So over here, we're going to look up cobalt. Cobalt is multivalent, and cobalt can be CO2 plus or CO3 plus. So if there is no metal, then we can look at the information about products, but we can't predict unless we have enough information there. So cobalt can be CO2 plus or CO3 plus. Third thing is to write the word equation for the reactions, and we have two reactions because we have cobalt 2 and cobalt 3. So cobalt plus sulfur can yield cobalt 2, and then sulfur is going to become sulfide, or cobalt and sulfur can combine to produce cobalt 3 sulfide. And then once I have the word equations, I can come up with the chemical equations and balance those. So first is cobalt and sulfur, and we said that we know that that is S8, so that you can add to your data tables if you haven't already. And cobalt 2 sulfide, so cobalt is a 2 plus for cobalt 2. Sulfur is in group 6, and so it's a 2 minus. It's going to gain 2 electrons to have a full stable valence shell. So those are going to combine in a 1-to-1 ratio. So COS. So to balance here, I have 8 sulfur, 1 here. So I'm going to put 8 there. Now I have 8 cobalt, so I'm going to need 8 cobalt there. So that is the balanced equation for cobalt 2 sulfide. And if I have cobalt 3 sulfide, so that means 3 plus for its valence, sulfur is still 2 minus. So that means I need 2 cobalt for every 3 sulfur. So here I have CO2S3. So over here, I have 8 sulfur and 3 sulfur. So I need a number that both groups of 8 and groups of 3 can go into. 24 is the smallest number that both of those can go into. So 3 sulfur will give me 24 atoms of sulfur, and 8 molecules of cobalt 3 sulfide will give me 24 atoms of sulfur here. So that leaves me with 16 atoms of cobalt on this side, and so to balance that, I'm going to put a 16 over there.